Good day, everybody. We're given this question. Foremost, we need to have a circle. So we are asked to find R, which is the radius of the small circle. So we need to. Okay, so this is the figure we will be considering. Now I'm going to name them as AB is a tangent, AC is a tangent. So there are two tangents here. Now this angle is given as 30 degrees. AB is 12 units. Foremost, so I've already stated, right? We have to get R. R is the radii of the small circle. Now we see that AB is a tangent to the semi or to the circle. So let me give a name to the circle P. Okay, to the circle P. So by tangent theorem, so what is the tangent theorem? The tangent theorem states the radius of the circle will make an angle of 90 degree with the tangent, right? So let me drop a perpendicular from P to the tangent. So this is going to be 90 degrees. Okay, fair enough. Now excuse me, you see that there is also another tangent. Okay, so we also have AC as a tangent to circle P, right? So by two tangent theorem, AC and AB will be of equal length, and a line drawn through the point of intersection of the tangents, okay, will bisect the angle between them. Okay, you follow me? So that means if I were to draw a line between them, let me, okay, I'm drawing a line between them. This will bisect, okay, it will bisect the tangents and pass through the center. Okay, I think this is fair enough. It will bisect, so that would mean this 30 will have a 15 degree here and 15 degree here. That is critical. Okay, fair enough. Now we have to use one more theorem. So let me actually highlight the theorems we are using. So this is one theorem, tangent theorem, and this is the next one, two tangent theorem. Okay. Now there is another theorem we will use. You see the circle, point of tangency between the two circles. Now you see there is a tangency created by the circle with the semicircle. Now this theorem is sometimes called as the excuse me, radical axis theorem. Okay, this is the third theorem we are using. When a circle has a point of tangency with a semicircle internally, then the line drawn through the point of tangency will pass through the centers of the two circles. When we talk about circles here, the small circle and the semicircle. Okay, so if I were to connect these, the point of tangency, right, then if this is going to be a point of tangency, if I were to draw a line, then that line would pass through the centers of the two circles. That is a very important observation we will have to know. Okay, so this radius is r units. This entire distance, this entire AB is given as 12 units. So this is going to be 6 units. Now, I do not know, say, let me name it as an intermediate point called say D. Have I used D? Okay, let me use this as D. Let me take this as E. So this is R units. This entire thing is going to be 6 units, right? This is going to be 6 units. So this distance from 6 you take away R. So this distance is 6 minus R. This distance is R. And this distance, we do not know this distance. So we can assign some value for this. Okay, so let me take this as some, we cannot take this as, let me take this as some x. Okay, so that is going to be the figure we will be using now. So now what I'm going to do is, I'm going to be consider triangle PEO. Clearly, this is a right angle triangle. Right, there is a right angle here. I already mentioned the theorem for you. So let me use this side. Excuse me. This is a right angled triangle. So we can use the great Pythagoras theorem. So what is that? So this is the this is a triangle PEO. This is x, this is 6 minus r, and this is going to be r, right? So OE squared plus PE squared is equal to OP squared. Now this is 6 negative r squared, x squared plus r squared. This is going to be 36 negative 12r positive r squared and x squared positive r squared. Move this r to the other side, you get x squared is equal to 36 negative 12r positive r squared negative r squared. They get cancelled. giving you 36 negative r is equal to x squared. So let me take this as 1. Now go back to the figure. I'm going to consider PEA, right? Consider triangle PEA. So this is P, this is E, this is A, this is 15 degrees, this is R, right? This is R. This entire length is 6 positive x, right? So this entire length is 6 positive x. So what I'm going to do is I'm going to use the tan ratio. Now tan 15 is opposite side by adjacent side. Opposite side is R, adjacent side is 6 positive x. This is the formula. Now we need to get tan 15. So how are we going to do that? Now I'm going to use this formula. Tan of A positive B is tan A plus tan B divided by 1 negative tan A times tan B. So I can rewrite tan 15 as tan of 45 degrees negative 15 degrees. So in this case we will have to use tan of A minus B, which is tan A negative tan B divided by 1 positive tan A times tan B. So tan of 45 degree negative 15 degree is going to be tan 45 negative tan 15. Oh, I need to get 15 degrees. I cannot use 15 degrees here. I have to use 30 degrees. Okay. So this is going to be tan 30. Okay. Because we are not trying to get tan 30. We want to get tan 15. So we need to have 30 degrees there. Okay. Fair enough. So excuse me, tan 45 negative tan 30 divided by 1 positive tan 45 times tan 30. Now we know the following values. So tan 45 is 1, tan 30 degree is 1 over root 3. So how do I get this? See, tan 30 is nothing but sine 30 over cos 30. Sine 30 is 1 over 2. Right, cos 30 is root 3 over 2. You flip it, you get 1 over 2 times. This is going to be 2 over root 3. Right, 2 gets cancelled. You get 1 over root 3. So that is how tan 30 degree is 1 over root 3. Okay. So having got that, let me substitute the values here. Okay, so this is 1 negative 1 over root 3 divided by 1 positive 1 into 1 over root 3. This is going to give me 1 minus root 3 divided by 1 positive 1 over root 3. You take the LCM, you get root 3 negative 1 divided by root 3. This is root 3 positive 1 divided by root 3. Root 3 gets cancelled, giving you root 3 negative 1 divided by root 3 positive 1. I don't want to have square root in the denominator. I multiply by root 3 negative 1. I divide by root 3 negative 1. This is going to be root 3 negative 1 whole squared. Now this is a positive b times a negative b. This is going to be a squared negative b squared, which is root 3 squared negative 1 squared, which can be rewritten as root 3 negative 1 whole squared. Root 3 squared is 3, 1 squared is 1. So you have root 3 negative 1 whole squared divided by 2. We have to take that value and place it here. So if I were to take this as sum 2, so from 2 we have, what do we have? We have tan 15 is equal to r over 6 positive x. Now tan 15 is equal to what? Tan 15 is equal to this value, root of 3 negative 1 whole square divided by 2. So hence we have, so what do we have? We have now root of 3 negative 1 whole square divided by 2 is equal to r over 6 positive x. This is what we have got. Okay, so now we will have to resolve and make a substitution for x. Okay, so let me just expand this. So this is going to be root 3 squared negative 2 times root 3 positive 1 divided by 2 is equal to r divided by 6 positive x. So this is going to be 3 negative 2 times root 3 positive 1 divided by 2 is equal to r over 6 positive x. I add these two, I get 4 negative 2 times root 3 divided by 2 is equal to r over 6 positive x. Okay, so what I would do now is I will take 2 out. So this would be giving me 2 negative of root of 3 divided by 2 is equal to r over 6 positive x. So 2 and 2 can be cancelled, giving me 2 negative root of 3 is equal to r over 6 positive x. Now let me move this and bring this down. So this is going to be 6 positive x is equal to r over 2 negative root 3. I will multiply by 2 positive root 3 divide by 2 positive root 3. So this is going to be r times of 2 positive root 3 over, now a negative b times a positive b, this will give you a squared negative b squared. So 2 squared negative root of 3 squared. So that is going to be r of 2 positive root of 3 divided by 4 negative root of 3 squared is going to be 3. So you have r of 2 positive root 3. So this is my 6 positive x. Okay, but we have the, let me go to the point here from 1, right? We have x squared is equal to 36 negative 12r. Is it not? So from here I can rewrite x to be equal to r of 2 positive root of 3 negative 6. So I take this as substitute here. So this is going to be r of 2 positive root of 3 negative 6. The whole squared is equal to 36 negative 12r. I hope you are following this. So you square this, you get r squared 2 positive root of 3 squared followed by square of this, and then 2 times 6 times r times 2 positive root of 3 is equal to 36 negative 12r. Now this is rewritten as r squared of 2 positive root of 3 squared. Keep it like that. Expand this, or I would say 6 squared is going to be 36. Now I'm going to push this to the other side. So you have negative 12r positive 36 positive 2 times 6 is 12r 2 positive root of 3. Fair enough. Now this 36 and this 36 can be cancelled. So you have r squared of 2 positive root of 3 squared is equal to, now you have r and r. So let me take that out, and you have a negative 12 positive 12 times of 2 positive root of 3. Okay. Now when r and r can be cancelled, so you have r of 2 positive root of 3 squared is equal to, now this actually can be simplified. Negative 12 positive 12 times 2 is 24 positive 12 times the root of 3. So negative 12 added to 24 will give you 12. I can take the 12 out. Okay, let me have this step. 12 positive 12 times root 3. Now you bring this down. This is going to be 2 positive root of 3 squared. Now this is 12 of 1 positive root 3. You expand this, you get 4 positive 2 times 2ab, right? So it's going to be 4 times the root 3 positive root 3 squared. That's going to be 3. So 4 added with 3 will give you 7. I'm using this space here. So you have 12 of 1 positive root 3 divided by 7 positive 4 times root 3. So let me go to the next side and write. So r is equal to 12 of 1 positive root 3 divided by 7 positive 4 into root 3. So let me multiply this by 7 negative 4 into root 3 divide by 7 into 7 negative 4 root 3. This is going to give you 12 1 positive root 3 times 7 negative 4 into root 3 divided by 7 squared negative 4 squared times 3. So 16 into 3 is 6 3 is 18 1 48. 7 squared is 49 negative 48, you get 1. So this is going to be 12 of, you multiply 1 with 7 and then with negative 4 into root 3, and then 7 into root 3, and then negative 4 root 3 into root 3 will give you 3. So this is going to be 12 of 7, 4 times 3 is 12. So you have 7 negative 12 at one end, and then you have, I take root 3 out, you get 7 negative 4 at the other end. Okay, because 7 into root 3 and 4 into root 3 with a negative sign. So this is going to be 12 of 7 added with negative 12 will give you negative 5. Negative 4 added with 7 will give you 3 times root 3. So this is my R. Okay, now if you want, you can actually evaluate using a calculator. Say root of 3 is what? Okay, we can prefer to stop here, or if you want, you can evaluate the value of R. So root of 3, let me, okay, square root of 3. So what is that? That's 1.732. So 1.732 you multiply with 3, you get 5.19615, right? You take away 5 from that, right? It's minus 5, right? Multiply by 12, 2.353. So R is approximately 2.354. Okay, units. So this is a lovely question. Please like, share and subscribe everybody. Thank you.